Hey, what's up, guys? Welcome to another episode of the stream on the illus2D engine, where we are making a 2D game engine called the illus2D engine from scratch using C++ and OpenGL. So in the previous episode, what we did was we made a vector class. So if we take a look at this was our beautiful creation from the previous episode. Yep, we're streaming. Nice. So yeah, this was our beautiful creation from the previous episode. We basically wrote a vector3 class and a vector2 class, and we did some checking also here. It worked well. So on the code we got 0, so which means it went well. Okay, so let me get rid of this here, and in this video, hopefully you can see by the title, we're going to be delving into the world of matrices. Now matrices is a bit of a it's a bit of a complex topic than vectors as compared to vectors, okay? Because vectors are essentially just an array of floats, of just 2 and 3 floats in an array. That's pretty much what vectors were, okay? It was nothing particularly difficult to write a vector class. But matrices are a bit different because fundamentally, okay, so what the hell is even a matrix? Let me describe you that. So matrix is just matrix are just numbers that are arranged into rows and columns. That's basically what a matrix is. So let's say I have a matrix called matrix A, and I'll just assign it to 1, 2, 3, and 4. So this is a matrix, okay? This is a matrix because it has some data, so 1, 2, 3, 4, that's arranged into a row and column form. So it has 2 rows, so row number 1, row number 2, it's 2 rows, and we have column number 1 and column number 2. So there's 2 columns. So that's why we usually call these matrix 2 by 2 matrix. So the first 2 is for the number of rows of the matrix. The second 2 is the number of columns in the matrix. So this is a 2 by 2 matrix because it has 2 rows and 2 columns. Well, for us, we're probably never going to be using a 2 by 2 matrix, because for graphics programming, the most common matrix is a 4 by 4 matrix. So it's going to have 4 rows and 4 columns. So it's going to have pretty much it's going to have it's going to be a big matrix. That's what I'm trying to say. So if you guys just want a visual representation of what a 4 by 4 matrix looks like, so right now, so let's say we have a matrix called A again. Yeah, so we'll have a matrix called A, and I'll just make a big bracket for our 4 by 4 matrix. It's a 4 by 4 matrix. I'll put 1, 2, 3, 4, 8, A, B, C, D. Okay, so this is a 4 by 4 matrix. It has 4 rows and 4 columns. Now, why do we even need matrices? What's the deal with matrices? Well, the idea behind matrices is that we can use a matrix to multiply with our vectors in our shaders, okay? So we have this matrix, which is, in this case, is a completely arbitrary matrix. It's of no use to us, but let's pretend it's a matrix, okay? We can multiply it with a vector, for example, our position vector, so x, y, z, w. We can multiply with a vector. And the way a matrix vector multiplication works is that you multiply the first row with the first column. So we multiply 1 with the x, and we plus 2 with the y, and then we plus, and we do stuff like those. And we get the first row, and we do the same thing. We do this with this, this with this, this with this, and then we get a new vector. Okay, that's what we use matrices for. We use matrices to basically transform our vectors. Now we can have multiple type of matrices. We can have a scaling matrix, which scales our vectors, which makes our vectors bigger. Okay, we can have a rotation matrix, which kind of rotates our vector, and we can have a translation matrix, which basically translates our vectors. Okay, means it changes the position of our vectors in an arbitrary direction. Yep. So that's why matrices are extremely useful, and that's the reason why we are doing this matrix class so beginning in our so that's why we are doing this matrix class in the beginning of our series. So that's basically what matrices are. We'll probably get into I mean there are a lot of things that I have to explain before I actually do some stuff. So What I'll do is I'll just start writing the matrix class, and I'll just explain on my way as I'm doing the matrix class. That's basically it. Okay, cool. Alright, so but before this, I'll make a folder here in our maths. I'll call it matrices. I'll also create another folder. I'll call it vectors. Let's call it like vec and mat. I think it's much better. Vec and mat. I'll copy this into the vec folder, and if we do that, we of course have to include files/mathematics/vec, and we'll have to do this here. Cool. It should be working. Let's run the code. And it's taking time because my computer is slow, and yes, it works beautifully. Okay, cool. That's our vector class we had from our previous stream, so get rid of that. And we'll begin just writing our matrix class. So I'll add a new item. It will be called this will be header file first, be a mat4.h. I'll add a new item. It will be a mat4.cpp. Okay. Here we have our matrices classes. .cpp, and I'll just include this right away. I'll include files, mat4.h. Cool. Yeah, let's get into writing the matrix class. So like I said, matrices are just data that are arranged into a row and column form, which means that we can use multi-dimensional arrays for it. So we can use like instead of using some regular arrays, which we can also make vectors out of using regular arrays, but for this maths library, I'm going to be using multi-dimensional arrays. So that's how we're going to be tackling this issue of writing a matrix class. All right, so let me write the class mat4. It's going to have to add a couple of private members. I will have something like a array of floats. So for mat4 times 4, have for row for column. Have a public constructor. Gonna take nothing. Another constructor. It's gonna take a diagonal. The diagonal of the matrix. I'll set it to 0 by default. I'll set it to 1 by default. Actually, we don't need this here. I'm implementing this. So include mat4.h. We'll do mat4. So take a diagonal, of course. Okay, so we're going to have a couple of functions. So there are actually different types of matrices. There are like a null matrix, and we have like an identity matrix. So basically a null matrix is just a matrix. So I have a null matrix of 4 by 4. Basically null matrix is a matrix whose all the elements are 0. Okay, so we have all 16 elements in a 4 by 4 matrix as 0. So this is a null matrix. Okay, all the elements 0. And a identity matrix. So let me get rid of this. So an identity matrix is the matrix whose diagonals are 1. So I'll just get rid of this. So this is a so this is an identity matrix. The matrix whose diagonals are 1 is an identity matrix, and the matrix with all the elements are 0 is a null matrix. Okay, so we're going to make some functions to make our matrices either null or identity. So let's start. We do void make null. We'll set aside the void make identity. We'll do an identity matrix. Cool. Now let me implement those functions here. mat4 make null, make identity matrix. Alright, so we have this array for our matrices. Alright, so diagonal. For the constructor, we'll make a loop with I equals to 0, so then 4, increment the value of I, and we'll do mat4 over 4 to the I, so it's gonna get the diagonal. We'll set it to the value of the diagonal, basically that's it. Okay, cool. But before we do this, we have to make the matrix null matrix. Okay, because remember the identity matrix has a value of 1 in the diagonals, and everything else should be 0, else it is not an identity matrix. So first thing we have to do is make it a null matrix. So we'll do make null first, and then we'll do this basically. Okay, cool. The make null function is pretty simple. We'll do int, we'll just make we'll just pretty much copy this. We'll copy this and we'll just set every single element to be 0. That's basically what we do. Okay, nice. So that's our make null function. So we make the null and then we set the diagonal matrix. Actually, this is not how we make a null matrix. This is we have to use another loop here, which loops into the actual data of the rows. So z equals 0, so while z is less than 4, z plus, we'll just do mat 4 times 4 I. So the first index we'll do in j, we'll loop over j, set that to 0. Okay, cool. So that's our make null matrix. Okay, cool. Okay, make identity. So it's basically going to be this. We'll have to copy this to make the identity. We probably don't need to have this function because we automatically do it. Like if we pass the diagonal as 1 from the constructor, well, we make an object of the matrix. We probably don't have to need it. We probably don't need it, but I'll just keep it either, because if sometime we pass a different diagonal, then we can make it identity again. That's right. Okay, so we'll do 1 for that, and that's pretty much it. So make null, mat4, and make identity. Cool. I'll also put it inside a namespace. Of course, we have our own namespace. So namespace, I'll do inside the illus2D. I'll put it into a namespace with our mats. Cool. Cut this, paste it here. I will copy this to mat4, and I'll just do this. Gotta love Visual Studio. Okay, cool. Okay, everything's well. Awesome. So let's just check if our matrix is going well or not. Now, before I do, I'll probably overload the operator so that we can actually print the matrix. I'll just do it right now here. So I'll have to include IO stream for that. Include IO stream. I will write the method here. So below, it's inside the maths namespace. I'll do studio stream reference, of course. Operator. I'm going to take a matrix, so this will be a mat4. That's going to be a O stream first. So O stream reference stream. This is going to be a reference to a matrix. So mat4 mat. Sorry. I'll define the function inside here, down here. std O stream reference operator, comma, std O stream reference stream, mat4 reference mat. We'll probably make it const as well, of course. Const mat4 reference mat. Awesome. Okay, and we'll define the body. So we're basically going to print it to the console. So it's pretty simple. We'll make another for loop. So in I equals 0, lesser than 4 plus. So this is going to loop. So this for loop is going to loop over the rows, and the another for loop is going to loop over the columns. Not the column, the actual data in the rows. So j equals 0, j is less than 4, j plus plus. I'll just stream out the mat. I'll stream out something like of course we don't have the, of course we can't access the data inside the mat. We'll probably just make it public for now on. I'll just change it later. I'll change it later, guys, don't worry. So stream mat dot 4, so first row and the columns, that stream has an end line. For this we'll just return the stream. Basically that's all we're gonna do. So we push all of this stuff to the stream, and we get the end line and we return the stream. Cool. Should work. C++, the data. Let's just check it. I'll include. So we have already included it. Testing mats. Okay, so let's make a new object of our mat class, mat4. Mat. I'll just pass in a constructor for the diagonal. 1f. Now let's just try printing to the console, and let's check it. So we call the make null function, which so that's in 0. We have a then we set the identity. We could just yeah, we can just call it the diagonal. Cool. Let's run it. Hopefully we'll get a identity matrix, and we don't. So redefinition of following parameter. See declaration, redefinition of default parameter. Okay, solve this issue. Cool. So yeah, we do get a. See, so awesome. We get a identity matrix. We have the columns, the diagonal. Sorry, diagonal as 1. Awesome. Cool. So if I had to like format it in a way, I could probably just do something like this. So this. Let's run the code now. So hopefully see that. Yeah. See. So we have this matrix. So we have the diagonal 1, and the other is 0. Cool. We have a matrix class. Now this is gonna be, now the way I actually thought about it before I started streaming it, because I really want, because it's such a, because making a matrix class is actually a giant project. Alright, so basically the way I want to tackle this is I'm gonna make this mat4 class that we have right now. This is gonna be our pattern class, and I'm gonna make more classes for like scale, rotate, and translate, and they are basically gonna inherit from this mat4 class, because these functions right here, make null and make identity, those are mandatory functions that every single matrix class must have. So that's what we're going to do. We're going to make other matrix classes, and they are going to inherit from this mat4 class. So we're going to use some cheeky inheritance concepts here and there. That's basically what I wanted to say. Cool. Okay. Nice. Let's start making other matrix classes. So we'll make a matrix class for scale. Since it is, I'll probably make it a struct. Because since we're making everything public, I don't think it makes more sense to. Yeah, we'll just make it a struct for now. Right, so let's make it a struct, and this is gonna inherit from the public mat4. Awesome, cool. It's gonna have a default parameter. It's gonna scale. It's gonna take something like float. It's gonna take like a vector. So scaling. All right. So scale matrix. So I'll have to explain it again. So scale matrix. So how do you make a scale matrix? Well, a matrix that scales is actually pretty simple. So imagine you have a vector, okay? I have an x, y, z, w vector, okay? And I want to scale it. I want to make it twice the size as it is right now. So I want to make it 2 times the x. Not mandatory. Not twice the size in every direction. Let's say I want to make it 2 times in the x. I would have scaled it, let's say 0.5 on the y. So I want to make it like a bit fatter, I guess, fatter and shorter. And I want to make it like, I don't want to change the z, so I'll just keep the z as well, and I don't want to change the w as well. So how do we make this? Okay, so the way we do this using a matrix is we do this basically. So we have a matrix, so let's say we have a scaling matrix. What we actually do is we put the values in the diagonal. So I'll show you what I mean. So we'll put 2 here, 0.5 here, 1 here, 1 here, and we fill the rest with zeros. Okay, and this is our scaling matrix, because remember, when we multiply this with this matrix x, y, z, w, what's going to happen is this is going to get multiplied with this. Okay, so what will you get is 2 times x is 2x, plus 0 times y is 0, plus 0 plus 0, we get 0, and this we get multiplied with this. So 0 times x is 0, plus 0.5y, plus 0 plus 0. And this is going to multiply with this, so 0 plus 0 plus z plus 0, and this is just going to be 0 plus 0 plus 0 plus w. Okay, so in the end what we get is 2x, 0.5y, z, and w. Awesome. So this is a pretty this is pretty much how you make a scaling matrix. Okay, we put the scaling values in the diagonal of the matrix, and the other things must be 0. Okay, cool. So let's just make that matrix. Let me get rid of this. So hopefully you guys should know now how to make a matrix. And the electricity just went off. I hope that my microphone is not bad. There's freaking pockets in here. I'll probably have to make this a bit smaller. I hope my sound is not going to go. Yeah, because of the power cut, I have to make my voice smaller. Okay, so scaling matrix. So that's basically how we're gonna tackle this issue. Cool. Okay. All right. So what we need is we'll probably take in some parameters. Make.cpp, make.h will include maths vector 3.h. Good. We'll take some extra parameters here. It's closed for some reason. Incomplete type is not allowed. Okay. We'll take something here. We'll take a const vec3. I will take 3 by reference. Take the scale. We'll take s. So we'll take s for scale. Okay. Then we'll have some other functions. So we don't need to type these functions because we are inheriting from the natural class. Okay. Yeah. So let's just implement the function. Implement the class real quick. Struct. Perhaps. So here we'll make a scale thing. We'll do scale. Scale from the constructor. Const vec3 reference scale. S. I'll put some SC. C. And we'll just create the matrix. Okay. Alright. First, we have to make this a null matrix. Yeah, that's simple. We have to make this a null matrix. Null and then identity. So make null. Like identity. We probably don't need to make the identity, but we'll just rock with it, like the way they say. Then we'll just start a for loop in I equals 0 for I plus plus. So So we basically have to set the diagonal. So we do mat 4 times 4. So the diagonal I and I set it to be like sc dot x, and since we probably don't need this for loop, do we? Now that I think about it, yep, we probably we'll do this. We'll just do it like the conventional, basically. So we'll do at 4, we'll do 0. We'll just hard code it for now because we don't really need that thing. 0 0 would be sc dot x. Copy it. Times 4 basically. That's what I'm going to say. Times 4 times 4. 0 0 1 1 2 2 3 3. Don't need 3 3 for we don't need 3 3. So x, let's see that y. Okay, cool. That's basically it. We'll put the operator in the last. The operator in the last. And yeah, that's it. So let's check our scaling matrix. So we'll do mat 4 scale equals sc, we'll call it sc as well. We'll do scale takes in a vector 3, so vector 3 I'll just pass in something like scale it like 2 times an ax. We'll just do the same matrix as we did for the example. So 5 on the y, none on the z, and on the sprint in the scaling matrix, and then we'll just check it again. So this, run the code. Fingers crossed to get our scaling matrix, and we do. Yep. So get 2, 0.5, 1, and 1. Okay, cool. If I change something like the 1 to something like 5, see our matrix is changed. Okay, cool, awesome. So 2, 0.5, 5, and 1. 7. Of course, we get some errors. Just want to make the matrix look nice. That's why I'm doing this. Okay, 275 now. Awesome. Our matrix works. Okay, that's the main thing. Our matrix works. Awesome. So that's pretty much for the scaling matrix. Now we have another one. So we'll have something known as we'll have another one called a translate. Okay, so translation matrix. The way this is gonna work is, well, it's pretty simple as well. So I'll just make this struct first. Struct translate is gonna public mat4. Also translate, and it's going to take in a vector 3 as well by reference. So just tr for translate, maybe say const okay, cool. So the way translation, so I'll have to explain that as well, of course. Okay, so the way the translation matrix work is we do something like this. So let's say I have a vector of x, y, z, w again. And I want to translate it. Let's say I want to translate it. I want to make it go 2 units in the x. I want to translate the x value, the x component to 2 units in the x. The y component, I want to translate it to -2 units, so I want it to come back. And the z, I want to translate it to -5, the z, and w is just going to stay same. Okay, cool. So this is basically how we translate vectors, of course. How do you do it? Now, this is where the beauty of having a 4x4 matrix and the beauty of this homogeneous coordinate comes in. Because one of the reasons, because there are other reasons as well, one of the reasons why we use a 4x4 matrix and we use a homogeneous coordinate system because because it's going to allow us to do a translate. How? Well, I'll show you right now. So the matrix that we're going to use for translation is as follows. So let's say we have a translation matrix called TR. It's going to be something like this. So let's just make an identity matrix first. So we have our normal identity matrix. If I can't even make it properly, I'll try to space it evenly as best I can. This. Okay, so this is our identity matrix. So what we're going to do is we're going to put our translation values over here. So let's translate on the EX, translate on the Y, translate on the Z. Okay. Now the beauty of this is when we multiply it with our vector, that's why this is W. So let's see what's going to happen. So we multiply 1 with the X, we get AX. We multiply 0 with Y, get 0, 0 with 0, get 0. So W for the most part is going to be 1. So I forgot to mention that. So W is going to be 1. Okay, which is for homogeneous coordinate. If we are working 3D, the W is going to change after the projection matrix, but since we're not using the projection matrix yet, this is a model matrix, the W is going to be 1. Okay, so it's going to be X plus TX, because the TX is going to get more multiplied by 1, and something multiplied by 1 is the same thing. So here we have 0 multiplied x 0, we have y plus, we have ty multiplied 1, ty, so we have 0 plus z plus tz multiplied 1, tz, and then we have 1 multiplied by 1. Okay, cool. This is how we make a translation matrix. Okay, so we put our translation values into here. So it's 0 1 2 0 1 2, and we put it 0 1 2 3 here. Okay, that's how we make a translation matrix. Okay, cool. So let's just make that matrix right now. Let's implement the function. So I'll put a translate. We'll have to make null matrix. Of course, make identity. Again, we don't really have. I guess we have to make diametric identities for this homogeneous component one. Yeah, so yeah, you have to do it. So you have to make null first and then identity. You must do it. Okay. So we'll do mat 4 times 4. We'll have so 0. Copy 3 times. I'll put for 1, for 2. For this can be 3, 3, 3, and this is gonna be tr dot x, tr dot y, tr dot z. So we're just setting the third value from the index, so 0 1 2 3 to be the value we get. Okay, the value the user passes. Okay, cool. So this should be our matrix. If we go over here and try to print it, so CCR will make a TR, call it translate. Okay, 3. I'll put something like let's say translate it 2 in the x. So let's try to make it as our example. So 2 in the x, negative 2 in the y, 0.5 in the z, and positive w, because it's not our problem. In the TR matrix, and voila, see, our matrix is rocking. So we have 2, negative 2, 0.5, and awesome. Cool. Let me just change this to be something whole number so our matrix looks better. 2, 2, and 5 in the z. Okay, let's run the code, and there you go. 2, 2, 2, 2, 5, 1. Pretty cool scaling matrix. That's the translating matrix. Okay, awesome. So that's for our translate. Now for rotate. Now rotation is a bit tricky, okay, because rotation, let me just write the struct first. So struct rotate public map 4. So the rotation matrix is a bit tricky. Rotate or rot. Awesome name. I'll come over here and make the function. So the way you do rotation actually is there's actually some. It's actually hard. Rotation matrix is actually hard as compared to scaling and transition matrices. Okay. Okay, so the way we do it basically is we do a couple of things first. Okay, we do a couple of things first. So the way we rotate a 3D object or a 2D object is we rotate it around an axis. Let's say let's say let's talk about only 2 dimensions as well, and we'll get into 3D later. So you have 2 dimensions, we have the x-axis and we have the y-axis, right? We have the x and the y-axis. So if you want to rotate it around, so we either rotate around the x or the y or both, okay? Let's say I have a vector a. I have vector a that's pointing to some point here. Let's say it's x and y, okay? If I want to rotate it around the x-axis, it will rotate around the yz plane. Okay, so it's gonna come out from here. It's gonna come out. It's gonna go in. It's gonna come out. Go in. Okay, that's how we rotate around the x-axis. Now the rotation around the y-axis is gonna make it rotate around the xz plane. So it's gonna rotate from this. So rotating around the y-axis would be rotating it around like this. Okay, it's gonna come out of the screen, go into the screen, out of the screen. Okay, so this is a bit complicated. And the rotation around the z-axis, so let's say this is positive z, and the inside is negative z. If you rotate around the z-axis, it's gonna rotate in the xz plane. So if you have this vector, it's gonna rotate like this. Okay, it's gonna rotate like this. Okay, so it's a bit difficult to do it. And there's actually, the way we get these matrices is not simple. We have to pretty much do some trigonometry, some mathematics to actually derive the matrix equations, the actual equations for the rotation matrices. So since it is a bit tough, what we'll do is, of course we don't have enough time to like pretty much sit down and derive everything from scratch. We'll just go to Google, go to google.com. I'll search for rotation matrix along x-axis from this. So okay, so this image right here, yeah, okay, so this is that. So this is, I'll just save image and my desktop, call it something like rotation. Holy hell, call it rotation. Okay, so I'll just get rid of this. Okay, this is our matrix. Okay, this is how we get the matrix. So rotation around the x is this, on the y is this, on this is this. So what we'll do is we'll just implement this straight into our code. That's basically what we're going to do, because we don't have time to derive this from scratch, and it's also not important as well. It's not important to know how to. If you want, I would probably give a link. I'll probably share a link in the description sometime for the derivation of this formula. But for now, we'll just implement it because it's not necessary for us. Okay. Cool. Should there answer? Okay. Okay. So rotate. I'll just add basically that message. So first we'll have to check like if it's rotation around the x-axis, the y-axis, or the z-axis. So we'll do if, so rot.x, so if it is around the x-axis, else if, so it's rot.y, else if it's rot.z. Okay, cool. So if that's the case, what we'll do is, so this is the matrix, this is the matrix. So what we'll do here is we'll just set it up basically. That's what we'll do. Alright, so rotation around the x, so it's going to be now 4 times 4, our actual matrix. The 0 index, the first row is going to have nothing. So as you can see here, it's going to have nothing. The first row is going to be 1 and 0, 0, 0. So nothing here. The second row, so the row from the second, and the second column. The second column is going to have a cosine of the angle. Okay, it's an angle. Of course, we don't have these functions yet. We'll have to go see math for it. Hopefully, should be able to use this. We have the cos function and the angle, which we will have to take in from the unit. So floor angle, copy this, put it over here, somewhere over here. Floor angle, so cosine of the angle, have to copy it 4 times. So the second row, from the second row, third column, have a negative sign of the angle. Third row, actually this is first row. Well, since our rows and columns start from 0, it should, the second row should be 1. Okay, my bad. First row is the column, doing this, and third row, second column should be sine of theta, sine of the angle, and we'll have third row. Oops, electricity is back. Time to get back to my. Well, I guess I'll just do it and then I'll get back to it. So now for third row, third column is going to be cosine of angle. Yep, it's okay. So let me just check it quickly if I've done this well or not. So alright, 0 0 is going to be 1 0 0. Second row, so this is second row, second column called cosine of angle. That's good. Second row and third column, negative sine angle is good. Third row, second column, sine of angle is good. Third row, third column is going to be cosine angle. Okay, cool, it's good. So we'll copy this. Actually, we'll not copy this. That's basically our rotation around the x-axis. Okay, let's just make it for the rotation around the y-axis. Bet. So there. So let's see what the matrix actually is. So the y-axis has cosine 0, sine 0. So it has 0 0. 0 0 is going to be cosine of the angle. Copy it 4 times. This is going to have 0 2. Have a sine of the angle, and then we have 0 1 2. So 2 0. 2 0 is going to have a negative sine of the angle. Have 0 1 2 2. 0 1 2 2 2 is going to have cosine of the angle. Okay, cool. Let's make it look like this. So it looks pretty. Okay, cool. That's pretty much it. That's pretty much for the rotation around the y. Okay, so rotation around the z is gonna have some stuff as well. We'll have cosine of theta here, cosine of theta, negative sine of theta. So 0 0 is gonna have cosine of angle. 4 times 4, of course. Probably do something. Okay, 0 cosine angle, 0 1, negative sine of angle. Negative sine of angle. Zero 1. So 0 1 and 0, so 0 is going to have a sine of angle. So 0 1, 0 1, cosine of angle. So 0 1, and 1 is going to have a cosine of angle. Okay, cool. Cool. Should be done. Yep, this should be our matrix. This should be our matrix. I'm correct. Yep, it's all okay. It's all good. All good. Yeah, that's our rotation matrix basically. That's what I want to say. I'll just make this drawn. So we have scale transitors. Let's just check it. Let's check it. We might not check it real quick. Let me check it real quick. We'll do scale, rotate. We'll do vectors 3. We'll make an instance of vector 3. Call it something like, we'll sort of have to give an angle, so we'll do 45 degrees. And for vector 3, we'll do something like, let's rotate it around the z-axis and let's see what we get. So 0 in the x, 0 in the y, 1 in the z. Call it rot. That's from the code, and let's check. This is well under so z, which means that we should change the first two. Yeah, see, so z-axis. So these values are changed, which you can take a look. Rotation. So z-axis means the first two and the second two. First, second two, those are changed. Others are 1 and 1. Okay, cool. So it works. Cool. And also, by the way, I think we should probably send these values to radians, because the cosine function, actually the sine and cosine, the trigonometric functions in C++ expects these to be in I believe in radians. Okay, and I'll do the microphone. Properties, go to levels. Cool. Okay, so the thing is that the C++ trigonometric functions, what's going to happen? What happens is that these expect the angles to be in radians. Okay, and since we have Visual Studio just crashed. Well, great, Visual Studio just crashed. Task Manager, let me get rid of Visual Studio. Hopefully our data is okay. 100% CPU for some reason. And by the way, my YouTube is showing this error for some reason. I don't know why. I hope the stream does not get stopped, for the lack of a better word. Okay, fine. Our matrices are okay. Okay, cool. Let's run again. My god, I hope the stream is going okay. Yep, the stream is going okay. Okay, so we see the matrices all this stuff. Okay, cool. Okay. Let me go to map photo CPP. I changed everything. Alright, so basically what I was trying to say is that the trigonometric functions of C++ expect the angles to be in radians, okay? But we are supplying it in degrees, so we have to change the value to radians. And the formula to change the value of degree to radians is, I believe, degrees times pi over 180, okay? So we'll have to do it. So I'll probably do this in a maths thing right here. I'll add a new item. I'll call it something like I'll probably define it. Make a header file. I'll call it like constants.h, and here I'll do define. I'll define pi as 3.14159. That's our pi. We'll define 2 radians. 2 radians. We'll x. What we'll do is we'll change this with something like, so we do x times pi over 180. Okay, that's basically what we'll do. So this is our little function, kind of, that's going to convert our macro, rather, it's going to convert the degrees into radians. Okay, cool. Yep, that's basically it. Let me go to map photo CPP, And let me actually check it. I hope this works. I'll include maths constants.h. I'll try to 2 radians. I'll convert like 180 to radians. Hopefully you get the value of pi. If we get 3.141, okay, 3.1. Cool. So it works. That's cool. Get back to my matrix. Okay. And I'll include this into constants.h. This into mat4.h. I'll include maths constants.h. And what we'll do here is actually we don't need it, do we? Yeah, we don't need it. We can just pass in from. We can pass our values directly from the. We can just do like 2 radians. We'll do this. Okay. Cool. We don't need to. We don't need that in the matrix class. All right. Now let's see if it's going well or not. Okay, it's going well. Cool. And we're happy. Okay. That's pretty much our main transformation matrices, our scaling, rotation, and translation. Now let's get into projection. Okay, and the projection we'll probably have to deal with. Okay, so here I'll call it like transformation matrices. So transformation means scale, rotation, and transfer. That's what transformation. So let's get into the projection matrices. So we do projection matrices. Okay. So we'll have, since we're making a 2D game, we'll probably be using an orthographic projection, which is a type of projection where like like objects that have a higher g value, that have basically the objects that are farther away don't get smaller. That's what an orthographic projection is, as opposed to a perspective projection, which is used mainly for 3D games, where the objects that are farther away actually get smaller, which is like our real life. Okay, but since we're going to be using an orthographic projection, we'll just make a one orthographic projection matrix class. Okay, so we'll do struct orthographic. It's gonna inherit everything from mat4. Orthographic, it's gonna contain, okay, so it's gonna have a couple of parameters. So orthographic projection needs a float left, float right, float top, float bottom, float z near, and float z far. Okay, quite some parameters, I know. Do here to transformation matrices to our projection matrices, orthographic projection matrix. Okay, so let's copy it. Orthographic. Okay, so orthographic projection now. This also, again, this is like even this is also a bit challenging, just like the rotation matrix, except it's even more challenging than rotation matrix. Orthographic projection, we of course we cannot derive the orthographic projection now because it's going to take a lot more time. So again, what we'll do is we'll just go to Google, we'll go to google.com. Literally we're going to search for orthographic projection matrix on the Google. I'm going to go to images and let me see, this one, I guess. Yep. Yeah, this is correct. So 2 right and left, top, bottom, far, near, far. Yep. So we're gonna use this matrix right here. Let me check if there are like a lot more easier ones. Projection. well, basically this, yeah, this is gonna work. So we have this matrix. We'll pretty much just copy and paste this. Save image as, we'll save it to desktop, we'll call it orthoproj.png. We'll get the image of the orthographic projection matrix, and this is our matrix. So how would we do it? It's pretty simple, by the way. It's pretty simple again. We pretty much just hard code these values by ourselves. That's pretty much it, because our matrix is going to be fixed. It's going to be 4x4, so we don't need to care about the size. We can just hard code it. It's going to work perfectly. Okay, cool. Okay, that sounds going well. Alright, so let's make an orthographic projection matrix. So we'll do mat 4 times 4. So the first value is going to be 2 over right minus left. So the first column is going to be 2 divided by right minus left, and we'll do the mat 4 over 4. Second row, second column is going to be 2 over top minus bottom, so 2 over top minus bottom. Copy it more times. Third row, third column is going to be -2 over z near minus far. Okay, yeah, z far minus z near. Okay, z far minus z near. Okay, I have n far for some reason. To n, I hope it's not here. You have n far for some reason. I copied and pasted this, so let's see the error. Okay, cool. So this is it for thing. We also have these now. Okay. Okay, right. So we'll do right, left, top, bottom, far, near. So 0 and 1. I'll get rid of this. 0 and 1. Gonna be mat 4. Okay, so mat 4 times 4. 0 and 3. It's gonna be right plus left divided by right minus left. So negative right plus left divided by right minus left. Okay, cool. I will paste it for a couple of times, 3 times. Negative top plus bottom, top minus bottom. So top plus bottom, top minus bottom. This, and for this one it's gonna be, it's probably 1 3 2 3 1 2 0 1 2 0 1 2 3. It's gonna be negative far plus near, far minus near. So far z far plus z near gonna be z far minus z near. Awesome. Plus near, negative near, right plus top, right plus left, divided by right minus left, top plus bottom, divided by top plus bottom, far plus near, divided by far. Okay, cool. This should be pretty much it, as far as I can tell. We can just test it, of course. We'll test it right now. Okay, of course we'll have to call the make null and make identity. Actually, I don't think we have to, since because the constructor for this is gonna run by itself. So I'm not sure if we do have to do it. I think we don't actually. Yeah, well, we'll try by not doing it, because for rotation we didn't do it. So yeah, I think it works. Okay, rotate. We'll do mat ortho. Do orthographic. gonna take a couple parameters. We're gonna take left, so 2 on the left, so -2 on the left, 2 on the right, top, I'll put something like 2 on the top, 1.5 on the top, bottom, 1.5 on the bottom, z near, -1, z far on the bottom. Okay, cool. I'll print the ortho and let's see if it's okay or not. It should be okay. And we get this. Okay, 0, 5, -1. Yeah, it should be correct. I'll try to 10, -10. Okay, so this. Yeah, it should be okay. Should be good. Okay, that's our orthogonal projection matrix. We'll do math 4. Let's just double check it just in case. So 0, 0, 2 divided by right minus left. 1, 1, 2 divided by top minus bottom. 2, 2. 0, 1, 2, 0, 1, 2. My -2 divided by z far minus z near. So 0, 0, 1. 0, 1, 2, 3, right, negative right plus left, right minus left, 0, 1, 0, 1, 2, 3, negative top minus bottom, negative 0, 1, 2, 0, 0, yeah, cool, everything's going well. So my theory was correct. We don't really need to call this because the default constructor runs and we have this make null function in the constructor, so we don't really have to do it. Okay, and we can even check it if we, yeah, we'll check it. Just check it if we are confused. I'll make a mat 4 scale S scale like 3. I'll scale it 2 in the X, 2 in the Y, 2 in the Z. Print this. Okay, cool. We don't need that anymore. Awesome. Hold on a second. Yep, the W is on. Cool. Alright, so yeah, our things are working. We have our matrices. We have a transformation matrix kind of group, scale, translate, rotate. We have a orthographic projection matrix, traffic, and we have the operator to print it, and that's basically it. Now I want to do something else. I want to include operator overloading. Okay, so I'll here, so operator overloading. Okay, now I pretty much I don't need to do it. I mean, it's kind of optional. It's just if I want to check it in the if I want to check it, yeah, that's why I'm doing it. Yeah, it's just for testing purposes. I could just not do this part because it's not that important because we already have our config, our shaders. But the first thing what I will do is I want to, so what I want to do is, so this is an object, so I just want to be able to, like, from S I want to go this, I want to go this, and I want to access element 1 and from the second row, second column. Okay, I can't do that now because this S is an object. Okay, it's not a memory address. So let's just add that quickly. We'll do here, we'll go map4.h. Sorry, the chair, my chair is a bit it's not aligned well to align my chair well. Okay, so let's just implement that function real quick. So we'll do so we'll make it in the map4. We'll map4.h. We'll do something like flow. So this is gonna take a, so yeah, it's gonna return a flow. We're gonna overloading this operator. So I just want the address for now. Okay, I just want the address. So operator taking a, it's gonna take a const mat4 by reference mat. We'll probably define the function here. math4.cpp and math4.cpp. We'll have this for thing here, somewhere here. Put after this. I can't put it anywhere I want to put it. So math4 operator plus give me an error for some reason. Math4 operator that. Okay, constant. Okay. So the way this is gonna work is it's pretty simple. It's gonna it's just gonna return the address. So it'll gonna return mat.mat4.4. It's gonna return the address. Probably gonna make it return a address to a float if I'm good with that. Yeah, let's try and do this. So it's going to return a address to a float and it's giving an error. It's not match the type. Let's do a so you're calling this, we actually need a float index. Return a 4 float index. Okay. Error for some reason, incompatible. Declaration is incompatible, of course. We're gonna get a index, and it should just work, and it does not. It does not work. Unscoped email type. Oh, it needs to be an int. No, but never mind. We can just let's define this to be an integer. Int index. Okay, cool. Let's just check it real quick. I hope this works. So basically, I want to do this. I'll do here. I'll do std cout. So cout. So let's do s. First element. The first row. And it's gonna give us the address of that row probably. So we'll just check it. Hopefully, it's gonna print us a memory address. Yep, it gives an address, and from that we want to get the first element. So hopefully we'll get 2. And if we do, it's working. Yep, it's working. Let's try getting the 0 and the 1. So hopefully we get 0 printing, and we do get 0. Awesome. It's going pretty well. It works pretty well. So that's what I would say. Okay, cool. 0 0. Cool. And I can also do this. So bam, I can do that. It's gonna give me the address to that too. Just look at it, was absolutely essential. It's actually essential for sending the matrix data to OpenGL. Now so you have the operator, and by the way, I think I didn't tell you guys this, but this matrix class that we're doing is actually a row major ordering. The matrix is row major ordering because we're just making a 2x2, making a 2-dimensional arrays, and we're setting the data that way. OpenGL actually expects the matrix to be in column major. So when we actually pass our matrix to OpenGL, we will have to transpose it, which is not going to be hard actually. It's going to be easy actually. It's not going to be hard. There's a inbuilt flag in OpenGL for transposing the matrix, so it's pretty much okay. Alright, cool. That's pretty much it actually. It's a pretty good matrix class. Now I could just implement like matrix vector multiplication as well. It's probably gonna take some time, but you know what? I'll just do it. Yep, let's just do it. So operator overloading. Matrix. Okay, so operator overloading. I'll just put it over here. I'll make a function called it's gonna return a vector 4. Actually, for that we'll need a vector 4, because we have a 4x4 matrix and we don't have vector 4 class yet. So I'll probably just make a vector 4 class. You know, why not? Let me see. It's gonna take some time though. Should we do it? I mean, we can do it. It's not a big deal. Yeah, let's just do it. Why not? Let's just do it. Let's just make it this like the best maths library ever. Okay, vector 4.h. Let's do it. Let's do it. Vector 4.cpp. I'll literally just copy and paste this. Control C. Control V, vector 3.cpp, Control C, Control V. I'll have to change a lot of stuff here. Constant, save. These. Okay, vector 4.h. So first thing I'll have to change is I'll have to change this thing. I'll just change everything. Replace with current document. 3, replace with vector 4. That's all replaced. We'll go vector 4.cpp. We'll replace here as well. Vector 3 with vector 4. Replace all. 44 occurrences replaced. Cool. And we'll so vector 4. So vector 4 is going to have an additional component, the W component. For the homogeneous coordinate, which is going to be 0 by default. So W, we're going to take a we're not going to let the user modify it. We're not going to let the user modify the W. I mean, we could, but we're not. Basically, yeah, that's right. Vector 4, we're going to hard code the W to be 1. That's pretty much it. So get length, we're going to get the length, normal vector, plus add the vector, and we're going to return a vector of well, if we add a vector, we'll probably need to add the W component as well. So yeah, I mean, if the W is 1, we can just return this, and if it is now 1, we'll see how it will go. We'll have to add the W, don't we? I mean, what really happens when we add two vectors? That's kind of weird. I mean, if we add two vectors, we add the positions, the actual components, the x, y, z component, but you don't really add the W, I believe. The W is just for the rasterizer, so we don't want to mess with the W. Okay, we don't want to mess with the W at all. So yeah, this is all fine. We don't want to mess with the W at all. Cross product with all this, cross product all this, comparison vectors, relational vectors. Well, we can't compare the W. Yep. Yeah, we'll just leave. But of course, we'll have to print this here now. So vector W. Let me do this. Okay, cool. Should be it. So vector class is done. And vector 4. And then catch it. Okay, let's just check it again. Okay, so vector 4. I'm going to include vector 4, of course. Pound include files, maths, vec 4.h. Do vector 4, vec x, y, z. Imagine we get an error again. Of course we don't. So 1, 2, 3 negative. Oh my god. 1, 2, 3 negative 0 points, whatever this is. Okay, so let's see where we messed up. Of course we gotta take a float. So float W. which is not going to be anything because we don't want that user to do it. Float x, float y, float w, back 4.h. I think it's, yeah, we're providing a w by ourselves. Is that the reason? Hold on. Oh, I forgot to do that here. Okay, let's get the W now. Okay, cool. So we get 1, 2, 3, and 1. Okay, now it's solved. Now it's solved. I forgot to put that on here. Okay, cool. That's pretty much it. So vectors work. Testing mathematics. We get 2 printing to the console. Okay, it's all cool. Good. Yep, so let's just get into the vector matrix multiplication. We'll get rid of this. We'll get back to our mat4.cpp, mat4.h, and we'll add this. So projection matrix, matrix, so matrix vector multiplication. Alright, cool. There's going to be a function out in the global scope, of course. Alright, so this is going to be a function that's going to return a vector 4. So we'll have to include maths vector 4. Vector 4 operator star const mat4 reference match, and it's going to be const vec4 reference vector link. We'll implement it here. Matrix vector application. I'll literally just copy this, paste it here. Here, operator plus, okay, operator star. All right, so the way I'll have to whip up my paint again. Have to whip out my paint again, my friends. All right, so the way how we do it, so like I said earlier, the way we do it, so let's say we have this, so we have A, B, C, D, oops, I, J, did I forget my ABCs? Okay, cool. So we have this 4x4 vector, say 4x4 vector, now vector matrix. We have a 4x4 matrix, and we have a vector, say x, y, z, w. I have vec 4, right? So how do we do it? So like I said, we multiply this with this, so we do a times x plus b times y plus c times z plus d times w. Okay, so that's how we do it. Now for the next, we do e times x plus f times y plus d times z plus h, I meant to write h in there, h, so h times w. Okay, that's pretty much how we do it. It's not super complicated, it's kind of rather easy. Okay, so the way we do it basically is we'll probably hard code it again. Okay, yep. All right, so matrix, so mat, we'll make a new vector, so vec4 new vector, of course, awesome name. We'll return a new vector, not new vector, we'll return a new vector. What we'll do here is we'll add it, basically we'll multiply the two matrices. So we'll do new vec dot x is equal to, we'll do mat. Alright, so okay, so I'll probably be using a loop. Oh, hold on, let me just put it on next monitor. Put it here. So I'll probably have to find some algorithm or something like that to do it actually. So The way we'll probably do this is, should we may do it in a loop or something? I mean, we could make a loop and like loop around, make the data. But I'll just hardcode it, because if we make a loop, it's going to be even more difficult. Alright, so vector.x. We'll do mat 0, 0, so the first element times vec.x plus, we'll do, of course we cannot do it because we do none of the operator matches the operands for some reason, because okay, so mat 4 times 4.x. Okay, so vector.x plus, we'll do mat 4 times 4, so the second vector y plus, we'll do, I can just copy and paste it. I just copy this, paste it around here. Second element, third element was z plus fourth element with the w. Yes, cool. I will add for the remaining ones y, x, y, z, the w. So this is going to be 1, 2, 3 basically, and this is all that we need. Okay, cool. Of course I have to put this to be 1 to 3 here as well. So 1, 1, 1. So 2, 2, 2, 2. 3 is gonna have 3 in here, 3 in here, 3. Okay, cool. That's pretty much it. That's pretty much our matrix version 1. Now we have another one, which is vec4, the last one. So we have matrix multiplication, which is gonna be a real headache, but I will do it nonetheless, because it's gonna be the awesome maths library that's around. So we'll do it here. So matrix multiplication. So it's going to return a matrix. Operator star const mat for reference mat1 const mat for reference mat2 and yep, we'll do that. And what we'll do is we'll just define the function here. So copy this, copy it here, matrix multiplication, vec4 okay, cool. Operator star started mat4 as well. Okay, because it's outside, it's not in the mat4 class. Okay, cool. So let's make a new mat. Mat4 new mat, we'll return new mat. That's pretty much it. Okay, let's get into the painstaking matrix. Now this is gonna be a real pain to do, but we're gonna do it nonetheless because we're tough like that. Okay, we have this. We have a matrix. I'll have to draw two matrices. I'll have to be really wise with my space here. I have this first matrix. I'll call it A, B, C, D, F, G, H. Really want to be wise in the space. Oops. Okay, we have one matrix. And we have a second matrix. I'm probably gonna write in, if I write in my language, you guys will not understand, so I'll try not to do that. I'll just do it in, just a number, I'll just do numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2. Okay, cool. We have two nice matrices. We have two nice matrices here. Okay, matrix multiplication. The way this is gonna work is a pain. Like I said, it's a headache. This is gonna give us back a 4x4 matrix. We're gonna multiply this with this. Okay, then we add it. We do this with this. We add this with. We do this with this. We get a number. Then we do this with this. We get another one. This with this, we get another. And so this. Okay, so okay, I'll make it clear from start. Okay, this because it's a bit harder to understand. So for the first element, okay, for the first element we do multiply this with this. Okay, and we get the first element. And then multiply this with this, we get the second. And we do this with this, we get the third. We do this with this, we get the fourth. And then we just then we basically repeat it out from here. Okay, so how do we do? We are obviously gonna have to hard code it because there's no any kind of pattern. What we'll have to do is we'll have to do new mat. So how will he actually gonna do it? Let's see. We can probably make a loop because from here it's going to be same for here. So I'll probably make a loop for I is equals to 0. Well, I is lesser than 4 for the I plus plus. So it's not completely hard coded. We do have a loop. So I'm going to make a loop, and what I'm going to do is I'm going to set the matrices one. So we'll do new mat matrix 4. We'll get the row 0, so the first row, and into the row we're gonna get the columns. I'm basically gonna be so in the first row we're gonna get the columns. I'll copy it more times. First row we're gonna get first row, second data. So first row first data, first row second data, first row third data, first row fourth data. Okay, so this is gonna loop over to all our matrices. Now here comes the tricky part, is how we actually deal with it. Alright, so let's just try to make it. Let's just try to derive an algorithm. So it's kind of really hard to talk and think at the same time, but I'll try my best. So get rid of all this. Let's multiply this with this here. So map for I0 alright, so mat1 dot mat44 is going to be 0 in the row, 0 in the column, times I'm probably going to multiply it with so mat2 so basically we do have to do it. So mat2 is the row, so we'll have to do 0 and this dot mat4. Okay, so first data of the row multiply with that, second data of the row will multiply with that. Oh, it's gonna be well over. This might be 2 hours or something. I don't know. Okay. Multiply with that. So 0, so the first row into the first row, well, I can just do this, column number 0, then I can plus do mat1 dot mat 4 by 4. I will do first row second data, multiply that with the second row first data, so mat 2 times so second row second row first data. Okay, cool. Yeah, this is first row first data, first row first data. It's confusing as hell, man. Getting messages. Yep, this is really hard. So this with this, 2 times that, plus 3 times that. Yeah, well, yeah, I think I got it. Hope I didn't got it. So I0 be that. I want to change this I with every loop, so I just want to change the row into data. Yep, that's good. That's good. I multiply with change the columns. Actually, the column is going to stay the same. So we're setting the row first, so at for I0, so first row, first column, first row, first element, second row, second element. Yeah, so first row, first element, we'll do this with this. So with first row, first element, we'll multiply that with that. We'll multiply with second first row. Actually, I'll try to do this. That first row, second column. My brain is just froze right now. I don't know what to do. Damn, we're 1 minute 31 hour 30 minutes. Damn. Okay. First row, first column with this. I1 1 0. Yeah, I got it. So 1 and I, so we'll multiply it by 1 1 0 plus mat 1 down mat 4 times 4, multiply that with so we got the first, so we got I, so we got 0, we got 1, then we got 2 times 0 1 2, we multiply it with mat 2 dot mat 4 times 4, have a 1 0 2 0, and we'll have plus mat 1 dot mat 4 times 4, we'll have a mat 4 times 4 I3, multiply that with mat 2 dot mat 4 times 4, damn, this is a long one, times 4, it's gonna have a 3 0. Okay, so yeah, it should work. Start with all this to here, with this. Okay, cool. Okay, so I1, so let me just check it real quick. So I1, so I0, let me take it. Okay, cool. Okay, so the first element is gonna be, so this element is gonna be I0 multiplied by 0 0, I0 1 multiplied by 1 0, so this is gonna be this one. So I2 multiplied by this, I0 1 0 1 2 3 multiplied by 3 0. Cool. That's it. So for the second one, what we'll just do is we'll just increment that. So for the second row for the data, so for this one, what we do is, so we multiply this with this. Now we do this with that, right? So we'll have to basically increment this. So instead of doing like 3 0, we'll have to do, so basically instead of doing 0 0 0, we'll have to do 0 1 0 1. Yep. So we'll do that. 0 mac 2 4 times 4. So we'll have to do 0 1 here. 0 1. I'll put this on here. So 0 1. Do 1 1 2 2 and 3 3. I believe that's it. If I'm mistaken, I'm mistaken probably. Okay, okay. For the second one, we'll do this with this. We'll do A with I0 with I0. We'll multiply that with 0 1. Okay, and then we'll do multiply that with 0 1. Yep. There's another one, the column. We'll do 0 1 0 1. So we'll do again 0 1 0 1. Okay, so 0 1 0 1. That's good. I2 0 1 2 C multiply with 0 0 1 2 0 1. So 0 1 2 0 1 0 1 2 0 1. And the D should be 0 1 2 3 3 1. So basically instead of 0 we put 1, I guess. Yep, so instead of 0 we put 1. Okay, cool. We'll have to do with 2 here, I guess. So 0 1 2 0 0 1 2. So we'll put 2 here. We'll put 2 in here. Put 2 in here. Put 2 in here. Let me just check it. So second, we'll have to multiply this with this, right? So for second, we'll have to multiply I'm trying to explain and do it this at the same time, so it's really hard. So multiply this with this, we're gonna get a multiplied by 3. So this one multiplies. So for the second one, I0 multiplied by 0 2. So 0 0 1 2. Okay, good. I multiplied by 1 plus my 4 I was 1 plus my 4 I multiplied by 1. I'm completely lost again. 0, method 0 1. So method 0 0, method 0 1, method I 0. Okay, so 0 1 2. For this method I 1. Why is I 1? Oh. There's okay, so 0 1, so 0 1 0 1 2 plus method 0 1 2 0 1 2 we do with this, that, so, and then we have 0 1 2 3 with 0 1 0 1 2 3 0 1 2. Cool. Guess it is all about that. Now here I'll have to do 3 here. I'll do 3 0 1 2 3 here, 2 3 here, and I'll have to do, oh my goodness, 2 3 here. Okay, cool. Should be it if I recall correctly. This with 0 to 3 0 0 1 1 1 2 3 1. Yep. Yep, should be correct. Yeah, and then after this all we do is we do it for 4 loops. We loop it for 4 times and we return it. Hopefully it works. Weighted matching multiplication. Yeah, let's just check it basically. I really hope it works. So let me just make a matrix first. So I have the scaling matrix here. I'll make a vector. So vec4 vec, I'll call something like, let's say 1 1 1. Let me print. So here's what I'll do. I'll do vec. So I'll do s. I'll do this multiply, kind of like a multiply sign. Vec. I'll do this. So let me just see if this prints or not first. My stream is going for 1 hour and 37 minutes. Well, it's a new world record. Not world record, that's a new my record. Okay, so times this is equals to that. Okay. Let's do it. Let's do equal to. We'll do s times the vec. And let me check this again. Let me go to this overloaded function. This one's taking the vector matrices and the vector, and does that and returns a vector. Hopefully we'll get a 2 2 2 vector here, and we do 2 2 1. Awesome, pretty cool. So that function works. Now I want to check something else. I want to make a 2 identity matrices. So mate I1, I'll make a 1 identity matrix. Mate 4 is supposed to be, I'll make 2 matrix. Now I will just multiply these matrices together. So I1 times I2. Cool. So we get that. Let's multiply this with our scaling matrix. So if we multiply I1 with a S or S matrix, we should hopefully get to S times. Hopefully get our scaling matrix. We shouldn't get anything different from that. And we do. Awesome. So we do get the same matrix. So we do get the same matrix. And if I wanted to do something else, I'll probably make a translation matrix. So translate. I'll translate to something like mate 4 translate vec 3 one in the x, one in the y, one in the z. And if I have to do so, we should read it from left to right. So translate first and then scale. So scale first and then translate. Okay, cool. Fingers crossed, hopefully we get the required matrix, and we do. Awesome. So we have the combination of the scaling matrix in the diagonal and the translation matrix on here. And if we had to change something like 2 here, hopefully you see that get changed, and we absolutely do. 2 to 1, 1 to 1 1. Awesome. So yeah, holy hell, that took some time. It was 1 hour 45 minutes. This thing took a lot of time. I'm probably gonna write it here. This took quite a while to figure out. Okay, yeah, that's pretty much it. I guess. Do I have anything else? I'm probably gonna make it a const here. So if I do this, I can probably CPP like an error. Declaration is incompatible, of course the declaration is incompatible. Return but doesn't match function type. Why would you say that? It's the same function. We're returning a pointer to float array. I was trying to do something here. Check if this works or not. Does not match the function type. What do you mean? It does match the function type. It's a float. We're returning a float. And I'll just leave it. And I'll just leave it for now. It's working fine. I don't need to change anything. Yeah, that's basically it. This is our gigantic matrix class. Damn, it took a while, but the plus side is that now we are fully ready to get into all the shader stuff, all the shader magic, doing all the stuff on the screen, rotating, scaling it, translating it, and all the stuff. Yeah, that's pretty much it. Next video we're going to be setting up shaders, and look at the code. Damn, we have a lot of code. Next video we're going to be setting up some shaders. That's going to be fun, because finally from the next video, hopefully we'll actually be able to get that boring triangle and kind of like get something a bit interesting. That's what I was saying. Okay, matrices done, vectors done, mathematics done. Basically, that's it. I'll see you guys in the next stream. Next stream we're probably gonna do some shaders, and yeah, this is gonna be awesome. Next stream is gonna be awesome. I'll see you guys on the next stream. Basically, I've been saying next stream for so long. Yeah, that's pretty much it. Yep, goodbye.